All right, everyone. So what I'm going to do now is go over our first Khan Academy unit review. This one is called Summarizing Quantitative Data. What I'm going to do is I'm going to go through each example, but try to give you the bigger goal of each question. So some questions won't require me to write anything down, and so I won't. This one should go by pretty quickly, but we'll see what happens. So anyways, this is Summarizing Quantitative Data. It's 10 questions. Your questions will be different than mine, but I'll try to convey the idea of each question. All right, so in this question you have a data set and it asks you to approximate the location of the median and the location of the mean, So remember that the median is where the middle value of the data set is when you order it from least to greatest, and the mean is again the average of all the data points. One thing that we know is true is that if a distribution is, and this one is, skew left, in other words, this distribution has kind of a left tail to it. When that happens, that means the mean will be less than the median. Every time, guaranteed. And if it was skew right, then the mean would be greater than the median. So one question is, how many data points are there? There are 15. And if you also think about where the median is for 15 data points, here's where the median will be. You have 7 that are less than, you have the median in the middle, and 7 that are greater than. So the smallest 7, the largest 7, what's in the exact middle? Technically the 8th data point. So if we think about it like that, you can see that there are 1, 2, 3, 4, 5, 6 data points that are less than, or not even in this bar. All the rest are in this bar, so that means the 8th data point, no matter how you count it, the median is going to be in C. From there, if the mean is less, really at this point we're just guessing, but the idea is if you think about all these data points with the value of 3, A is probably not going to be the mean. It's probably not going to be 1.5 because all of those 3's are going to push the mean to probably be above 2. Of course, you can calculate all these things. It doesn't take too long to add up 8 3's, 2 2's, and 2 1's, or sorry, 3 2's and 2 1's, and a 0, and then divide by 15. You would get something a little bit above 2, but there you go. All right, up next, we have to order our sets from largest standard deviation to smallest standard deviation. So largest needs to go on top, smallest needs to go on bottom. The rough definition of standard deviation is the average distance of every data point to the average of all data points. All right, so what that means is if you look at all 3 of these, where my mouse is pretty much where the average would be. It's in the middle. If each of these had a weight on it and you were to like think of this as a scale, the scale would be balanced. That's where the mean is located, essentially where my mouse is. And the question is, which of these has data points that are furthest apart from the middle either way? And it's obviously this one right here. From there, the question between these two is which one has data points that are still more further away, and this is actually correct. This one, there are 3 data points to the left and to the right of the mean that are furthest away, and this one has the most data points closest to the center, the mean, and that means it's going to have the smallest standard deviation. So the further away all your points are from the average, you will get a larger standard deviation. The more data points that are closer to where the average is located, the smaller the standard deviation will be. All right, up next we have to say which data set could represent the box plot. This is probably going to be the worst example, just because you do have to do a lot of work here. But the minimum is 12, so we can knock out answer choice D right off the bat. The maximum is 24. There we go. And then remember that this bar right here and this bar right here are the first quartile and the third quartile, and this is what we call the median. All right, again, the median is the middle data point, and Q1 and Q3 are like the middle of the middle and the upper middle of the middle. In other words, this is 25%, 50%, 75% of all the data. So one thing we might want to do is count up how many spaces there are here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 for any set. So what I'm going to do is I'm going to visualize that like this. 4 to the left, 1 in the middle, that will be the median, and 4 to the right. So in other words, what that tells me is the fifth data point better be 19. And so we already eliminated answer choice D. The fifth data point for C is 20, so now C is gone as well. So now we know it's between A and B. The question is, which one probably has the correct first quartile or the correct third quartile? To calculate the first quartile, the median splits this in half, and now the question is, what is in the middle of 4 data points? And what's in the middle of 4 data points, I guess I should kind of write it like this, maybe. Maybe I'll do it like this. What's in the middle of 4 numbers? You will have to take the average of the 2 numbers. So we can see by this box plot the first quartile is at 15. The question is, for A and B, which one, when you average the second and third value, do you get 15? And that's true for B. Here the average is 16. All right, so that's interpreting a box plot. Again, this one's a little bit more specific to this question, but the idea is sometimes the median or the value you're looking for is directly in between if there's an odd number, but if there's an even number of things you need to find the middle of, you're going to have to average. Ooh, fun. Wow. This is so convenient. Now I gotta keep that going. Let me close this window and try to reload.